our demos all work kind of in the same way. We have pre-captured data that's already on the system, and we have set up a script that pulls in the data to WinLVS and then processes it appropriately. So in this case, we're using a multi-spot Eagle demo, so it'll be similar to what you were just talking about, where it would it should have many spots in it, and then it should process all of those spots at the end. And if I click the Start Script button, it's building up its image, and now we're done. So it's delivering the spots in a certain order, but since it's using the additive method and processing all the spots at the end, the script is always going to read the spots off in an order that it chooses, not in the order that they were delivered. So if we go over to QA plan review, we can say display current capture. And here it says we have 9 spots. And so even though they were delivered top down, the script is always going to read them in reading order, left to right and then top down. So here we can view one of these beams. This ought to look more like a proton beam than a laser pointer does. So once we have all of that data, we ought to be able to choose one of our Excel analysis styles. And so these ought to open up Excel, and it imports the data into Excel. It graphs, it gives you a little spot where each beam was on this graph. And then we do a systematic shift. So if your setup was a bit off center, a bit translated in X or Y, we can base everything off of where the center spot was with this particular script. Once we do that, we can compare the data we measured here. Actually, we're comparing this data to our nominal values here, which have been pre-input. So you can set up for whatever pattern you want. You can set up a set of nominal X, Y values. And then when you do this Excel analysis, it'll compute these for you. Was there a question?
That looks great.
Yeah, perfect for what we need, I think.
Okay, so let's get a little bit into this. This is our borderline and non-compliant distances. Again, if we change those, I believe things should go yellow or red. So let's say if we wanted to be very strict, a 0.5 borderline and a 1 millimeter non-compliant distance. We still have some that are good. One artifact is that since we're doing our systematic offset, the center point would always be 0, but these are also easy enough to get rid of if you choose not to do that, that offsetting. Over here, we've got a couple other graphs. How bad is your X or how bad is your Y axis? I think these beams are just placed by hand. So we have another type of script that'll go through, and it should build up over time. So every time you export, this is kind of a living spreadsheet. So you can see here there were previous deliveries that were input, and it's all the same data relatively because it's all off of the demo. But as you click that button, it deposits a new set of values, and it makes a little comparison here. And we have a plot of where all of your beams have been. And these are little spark lines. They're basically one cell graphs. So you can get a rough representation of how well things have been changing. And then these are all values that are based off of this data. So when we just did this, it input values into column R. So let me do Control S to save this document, close it, and if I just do it again, it should put all those values in column S. So if you have a daily QA or a weekly QA that you want to keep track of how things are doing over time, this is kind of a nice way to do it. You can do your delivery and import it into your trending template every time, and it'll just keep on going. Let's see. And these templates can all be changed so that you can use whatever patterns or add whatever graphs that you want to add as well. Just makes it a bit easier for you guys.